Hello students, now today we are going to discuss the Laplace transform. In lecture 4 already we have studied, that is your shifting property. By what is shifting property? In shifting property, if the Laplace transform in a shifting property of Laplace transform, what is shifting property? If Laplace transform of f of t is your what? That is your f of s, then Laplace transform of e to the power at f of t, Laplace transform of e to the power at f of t, that is your f of s minus a. If e to the power at multiplied with any function, the original function shifted to s minus a. If f of t Laplace transform f of s, if e to the power at multiplied f of t, the s can be shifted to s minus a, provided e to the power at means a is positive. If Laplace e to the power minus at if you will multiply f of t, then original function shifted to f of s plus a. That part already I told you in a previous lecture. So in a shifting property, whatever the Laplace transform of any standard functions or any function, if e to the power at multiplied, the original function s can be shifted to s minus a, if it is provided the function must be multiplied with e to the power at. If e to the power minus at is multiplied, the original function can be shifted to, if it is minus, that will be plus, if it is plus, that will be minus. So if I will tell you Laplace transform of e to the power minus at sin h omega t, hyperbolic function. In sin h omega t, so Laplace transform of sin h omega t. Sin h omega t is how much? If it is sine term, the numerator must be omega. So that is your omega divided by denominator is your a square minus omega square. If it is a hyperbolic function, and denominator must be a square minus omega square. If it is in sin omega or cos omega, denominator must be your a square plus omega square. In sin h omega t, omega by a square minus omega square. Here e to the power minus at sin h omega t. If I will say f of t, your original function is your what? Sin h omega t, f of t equal to your sin h omega t. So f of s is how much? F of s equal to omega by a square minus omega square. Then Laplace transform of e to the power minus at sin h omega t is how much? If e to the power minus at is multiplied, your original function is your sin h omega t. In case of s, you will put what? If since it is minus, that is your s plus a. So that's why this is nothing but is your what? Omega divided by, in place of s, you will put s plus a square minus omega square. If e to the power minus at is multiplied with the original function, the function s can be shifted to s plus a, provided this is nothing but a is minus. Similarly, if I will say Laplace transform of e to the power plus at sin h omega t, your original function is your sin omega h omega t. Sin h omega t Laplace transform is your omega by a square minus omega square. Since it is your e to the power plus a omega t, so f of s can be shifted to what? S minus a. So that's why this is your omega divided by, in place of s, that is your s minus a square minus omega square. It is all about your sin h omega t. If I will say cos h omega t, so if I will say Laplace transform of e to the power at cos h omega t is how much? So already you know Laplace transform of cos h omega t is how much? Since either sin h omega t or cos omega t, denominator is your a square minus omega square. Since it is a cos, numerator is your s by a square minus omega square. So if multiplied e to the power at into cos h omega t, the value is how much here? So that is your, if it is plus at, the function, original function s can be shifted to s minus a. So that's why in place of s, that is your what? S by s minus a, divided by s minus a square minus omega square. This is nothing but what? That is your, if a to the power at multiplied with the cos h omega t. Our original function is your cos h omega t. So cos h omega t, you know the standard functions or Laplace transform of cos h omega t that is your s by a square minus omega square. Since e to the power 8 is multiplied, that's why the function s can be shifted to s minus a. Similarly, if I'll say Laplace transform of e to the power minus 80 cos h omega t, e to the power minus 80 cos h omega t is your what? If it is minus, and s can be shifted to s plus a. That's why in place of s, that is your s plus a divided by s plus a square minus omega square. So it is about all about your shift using shifting property. How to find out? You can easily find out the Laplace transform of any shifted functions. So then now today again we are going to discuss another property, that is your what? That is your Laplace transform of derivative of functions. So Laplace transform of a derivative of functions. Laplace transform now Laplace transform of a derivative of a function. Derivative of a function. What is derivative of functions? So as you know, Laplace transform of f of t is your what? That is your f of s, or you may say f of t and f of s are Laplace transform pair. Means what? What is Laplace transform pair? So Laplace transform f of t is your f of s, and inverse Laplace transform f of s, that is your f of t. So if f of t is given, you can find out the Laplace transform with the help of Laplace transform, the time domain converted into frequency domain, that is f of s. If f of s, you have f of s, then you by the if you apply the inverse Laplace transform, so by inverse Laplace transform f of s, that is your f of t. But what is derivative of a Laplace transform? As you know, so d by dt, we are going to all about your time domain, any time functions to frequency domain, time domain to frequency domain with the help of Laplace transform. So d by dt of f of t, we can say d by dt of f of t is your what? F dash t. This is all about your Laplace transform, derivative of a functions. If I'll say Laplace transform of derivative of functions, suppose Laplace transform of f dash t is how much? Laplace transform of f dash t is your what? That is your s f of s minus f of 0. It is very important as far as any type of civil service examinations or some technical public sector exam. Suddenly a function is given with the help of some property. By using some property, it may be your shifting property, or you may be some derivative property, or maybe integrating property, you can find out the Laplace transform of particular functions. So if f of t is your f of s, Laplace transform of f of t is your f of s, so derivative of Laplace transform means the derivative of function f of t is nothing but f dash t. Laplace transform of derivative of function f dash t is how much? S f of s minus f of 0. So how Laplace transform of f dash t equal to s f of s minus f of 0? Let us prove. Then what we have to prove? We have to prove what? Laplace transform of f dash t is your s f of s minus f of 0. So you know Laplace transform of f of t is what? That is your 0 to infinite f of t into e to the power minus st dt. It is nothing but what? F of s. This is the standard formula of Laplace transform of any functions. So Laplace transform of f of t, when you are going to find out the Laplace transform of any function, means what? The integration is must 0 to infinite that function into e to the power minus st dt, and it is all about what? F of s. How to become f of s? Because here t dt and minus coefficient is what? S, that is your f of s. You have to keep in your mind the if a standard formula is there, and easily what you will find out what is the Laplace transform. This is nothing here f of s. Similarly here, now we are going to prove Laplace transform of f dash t, that is your s f of s minus f of 0. Laplace transform of f dash t is how much? So already I told you Laplace transform of any function. Laplace transform of any function equal that function to e to the minus st dt. So Laplace transform of any function is what? That is your 0 to infinite is must that is your f dash t, f dash t. Laplace transform of f dash t is how much? That is your what? 0 to infinite, that value f dash t into e to the power minus st dt is must. So Laplace transform of f of t is what? F of t into e to the minus st dt. This is a standard formula. So 0 to infinite Laplace transform, we are going to find out the Laplace transform of derivative of functions. The derivative of a function means f of t is your functions. The derivative of f of t is your f dash t. Now we are going to find out the Laplace transform of f dash t. So Laplace transform of any function is your that function into e to the minus st dt. So there are two functions by using integration by parts. If there are two functions, that is your formula is what? Already I told you that is your integration of first function into u into dv, u into dv. So that is your u into dv, u into dv, that is your what? U into v minus v into integration of d. But the first function into integration of second, dv integration is your second function, first function is u, second function is your dv, first function into integration of second, integration of dv, that is your v minus integration of second, that is your v into differentiation of first. Similarly, this is your first function and this is your what? Second function. So that is what? This is your first function, this is your first function and this is your second function. The first function is your u. U is nothing but what? That is your u, that is your e to the power minus st, u into v, f dash t. Integration of f dash t dt is what? Integration of f dash t dt. Integration of f dash t dt is how much? Integration of f dash t dt is nothing but what? F of t. If you differentiate, integration cancel, this is nothing but f of t. Integration of f dash t is equal to f of t. Similarly, e to the power minus st into what? That is f of t, u into v, f of t. And the limit is what? 0 to infinite minus v into du. V is what? F of t. This is your f of t into du. Du, first function e to the minus st, e to the minus st, e to the minus st. Second function f dash t dt. First function is your what? E to the power minus st. And here f of t, v into du, e to the power minus st, derivative of this is nothing but what? E to the power any function, the derivative is your e to the power that function, that is your what? So d by dt of e to the power minus st is nothing but what? E to the power minus st with respect to t, that is your minus s, that is your minus s. Minus s into e to the power minus st. And this is minus plus, and this is nothing but is your what? Into s into e to the power minus st dt. And limit is your 0 to infinite. Remember, now we are going to find out the Laplace transform of a derivative of functions. If f of t is your function, derivative of f of t is nothing but your f dash t. And here Laplace transform of derivative function, that is your what? S f of s minus f of 0. So we are going to prove Laplace transform of f dash t is your s f of s minus f of 0. So now this is a standard formula. The Laplace transform of any function f of t, that is f of t into e to the minus st dt, is nothing but f of s. So now Laplace transform of f dash t is what? F dash t, that function into e to the minus st dt. Here there are two, using product rule of integration. First function is your what? E to the minus st. Second function is nothing but what? F dash t dt. So u into v, first function e to the minus st, v, f dash t dt integration is what? F of t, 0 to infinite, minus v, minus the v is nothing but what? F of t, du, differentiation of e to the minus st is your minus s, e to the minus st. Here minus plus, f of t into s into e to the minus st dt. The value is how much? So that is your Laplace transform of f dash t is your what? If you put the upper limit infinite minus e to the power minus infinite, that will be 0, and e to the power 0, that is 1. And here that is your first, if you put infinite, that is your 0, minus that is your 0, e to the power 0 1, that is your f of 0, plus here that is your what? 0 to infinite, that is your s taking the left side of the integration f of t into e to the power minus st dt, and the value is how much here? This value is nothing but what? Can you tell me what is this value? F of t e to the power minus st dt. F of t e to the power minus st dt is nothing but what? F of s. That is your s f of s. And here, therefore, the Laplace transform of f dash t is how much? That is your minus 0 s f of s. Here s f of s minus f of 0. This is all about is your what? Laplace transform of derivative of functions. So Laplace transform of any functions, the f of t is your f of s, then Laplace transform of derivative function f dash t, that is your s f of s minus f of 0. So now to students, now next class we will do more and more number of problems related to that is your Laplace transform of derivative functions and Laplace transform of integration of functions, and how to apply these are the basic functions to like your DC networks or AC networks. Thank you.